Hey there, everybody. Mr. Depew here. Welcome to another week. Today, I want to talk to you about a project you'll be doing either this week or next week. I believe it's 6.05 data observation. You have two options. You can do it by yourself. You can do it with some other people. It really is just easier to do it by yourself, but that again is your choice. You will need 2 coins, preferably a carpeted area, and a piece of paper that you have numbered from 1 to 100. The project's going to ask you to flip 2 coins, quarters of the best, flip them each 100 times. You need to do them together. So get your paper numbered 1 to 100. If you have to use both sides of it, that's okay. If you're just going to use tallies, that's okay. This is like your work page. You're not turning this page in. So you're going to flip both coins. You've got to pay attention to which coin is which. You flip the first coin, it's heads. You flip the second coin, it's heads. Then you're going to write down for that first flip, heads, comma, heads. Okay? And they're going to ask you to put it into a table. Okay? There's an example of a table. Your results, either it's going to be both heads, both tails, or one of each. And then you're going to compile all your tallies at the end. This should total up to be 100. Now, don't use these numbers. That's just a hypothetical. You've got to actually flip the coins and keep track. What I want to talk to you about is this. If I'm flipping the coins, these are the possible options. You have to think about what are all the possibilities. So the first coin could be heads and the second coin could be tails. Or the first coin could be heads and the second one could also be heads. Those are 2 possibilities. The first one could be tails and the second one could be heads. Or the first one could be tails and the second one could be tails. There are no other possibilities with the 2 coins and keeping them separate as independent events. Think about that when you're going through it, because then you're going to be answering the questions. So in blue here, I've told you when you're submitting this assignment, you have to make a table, which is this. And then you also have to answer the 7 questions that are there. Okay, the first 6 questions are, what is the theoretical probability that they're both heads? And number 2, what's the experimental probability that they're both heads? 3, what's the theoretical probability that they're both tails? What's the experimental probability that they're both tails? 5 and 6, what's the theoretical probability that there's one of each? And what's the experimental probability that there's one of each? And number 7, it asks you to define the difference, or why would they ever be different? Why would your theoretical and experimental ever be different? I'm going to talk about that in just a second. But let's first of all talk about those first 6 questions, theoretical and experimental, okay? When I'm looking at this, there are a total of how many options? Okay, there's 4. 1, 2, 3, and 4. Out of those 4 options, how many of them say that they're both heads? Just the 1. So 1 out of 4. That should give you your theoretical probability that they're both heads. In the same vein, how many of them are both tails? Well, only 1 out of 4. Again, that should give you your theoretical probability that they land up on tails. How many out of 4 have 1 head and 1 tail? Well, you have this one and you have this one. So you have 2 out of 4, okay, which can obviously be reduced to 1/2. That's your theoretical. So all those are your theoretical. You can figure theoretical out before you ever do the experiment. So think about that. Okay, I'm going to flip this over. We're going to talk about theoretical and experimental. Zoom in a little bit here. All right. So theoretical probability, here's an easy definition. Theoretical is what should happen, what ought to happen. Okay, so when I flip a coin, it's a 50-50 chance it lands on heads and tails. We all know that. So theoretically, it's 1 out of 2. Okay, so theoretical. But when I do that experiment, it may not always happen that way. If I flip a coin 10 times, I could get 9 times heads and 1 times tails. It's not always going to be 5 and 5. So that's where experimental probability comes in. Experimental probability means what actually does happen. So when you do the experiment, what did you actually get? When I actually did this experiment, I got both heads 28 times. I got both tails 20 times. And I got 1 of each 52 times. That's what actually happened when you do it. Okay? Now your numbers are going to be different from this again, but that's an example. One last thing. Relative frequency is a term they're going to throw out there, and it means the same thing as experimental probability. So if they ask you to compare the relative frequency with the theoretical, then do that. But if they ask you to explain the difference between the relative frequency and the experimental probability, they're the same thing. So keep that in mind. Those are 3 main terms that you need to know as far as vocabulary. Hopefully that helps with this experiment. Give us a call, send us a question, anything that we can do to help out. Have a great week.